Hey guys, welcome back to another video. In this video we'll be officially starting unit 2, which is going to be on derivatives. So first, today in this video I want to talk to you guys about what exactly is the derivative and what it means. Next, after I do that, I'll be talking about the limit definition of the derivative, which is also known as a difference quotient. So with all that being said, let's get started. So before I introduce to you what the derivative is, let me introduce to you what the tangent line problem is. So let's say that we have a function, okay? And let's call this input value point A. So let's say that we had a line tangent to this function at point A. Now, recall that when a line is tangent to a function, that means that it's only touching this one point, okay? So what if you wanted to find the slope of this line? Well, that's actually what the derivative does. So by definition, the derivative, when you take the derivative of a function, you're finding the instantaneous rate of change at a specific point, okay? Now, to put it in more simple terms, all the derivative is, it's asking you what's the slope of the function at a specific point. So if we wanted to take the derivative of this function at point A, then the derivative would just be equal to the slope of this tangent line, right? So I want to talk to you guys about the notation to take the derivative of a function. Let's say a function is just f of x. That's our function name. The notation for that, there's several ways to write it down. One is d dx, the derivative with respect to x of the function f of x. Or another common way to write it is f prime of x is also equal to this, okay? Now, something that you need to know for the AP exam is something called the difference quotient, as I already mentioned. I'll write the difference quotient right here for you, then I'll explain to you what it actually means. So this right here is known as the difference quotient. It's also known as the limit definition of the derivative, okay? So I'm not going to explain to you what each of these parts means because you don't necessarily need to know that for the exam, but I do encourage you to go learn that, but just not on this YouTube channel because I'm tailored specifically to the AP exam and that just be considered irrelevant information. But the limit definition of the derivative is just the standard way to calculate the derivative of a function, okay? Like, let's say that you wanted to take the derivative of f of x when it's equal to x squared. You can use the limit definition of the derivative to do so. Now, what this does is it takes the derivative of the function, okay? So, if you use this on this function, what happens is you'll find the rate of change of this function, aka the slope, which is also known as what? The derivative, exactly. Now, it's not as common, but you may encounter the alternate form of the difference quotient. Now, it's pretty similar in structure, but I'm just going to write it down for you. That's a h, by the way. The limit as h goes to 0 of f of a minus f of x over h. Now all this, now the only difference is this f of a. This is just the function evaluated at a certain point, okay? So don't get messed up by that. Now let's look at some examples. Let's use the limit definition to evaluate the first derivative of f of x is equal to 3x. Now you may already be able to calculate the derivative based on what I just said. The derivative is simply the slope of the function at any given point. Now this is just a linear equation, so you could just say that, oh, the derivative is just 3 because the function is 3x and m is just equal to 3. Okay, well, let's look at how to use the limit definition of the derivative to calculate this, because that's the entire point. So let me just write it down for you again. So you're going to have to substitute x plus h into the function. So 3 times x plus h minus 3x over h. You can expand this. It becomes 3x plus 3h minus 3x over h. Now these terms actually start canceling out. Now you're left with the limit as h goes to 0 of 3h over h. Now these h's just cancel out, so h is going to be 3, as you might have already seen from this linear equation. Now things get a bit more tricky when you start encountering other functions that are not in standard linear form, y equals mx plus b. Let's say that we wanted to calculate the derivative of x squared. Okay, well, we're again gonna have to use the limit definition of the derivative, aka the difference quotient, to evaluate this. Now this is gonna be a bit longer, but we can still do it. Okay, I'm gonna write this down once more for you guys, okay, so you can reference this while I'm doing the problem. So let's substitute it in. So x plus h squared minus x squared over h. Okay, so let's expand this. Minus x squared all over h. These terms cancel out. Now you're left with 2xh plus h squared over h. Now you could actually factor out an h, and that'll simplify this down even further. So what that does is that gets rid of the h in the numerator and the denominator. Now we're just left with the limit as h goes to 0 of 2x plus h. Now, as I already taught you from my limit series, you could just try direct substitution here. So this just becomes 2x plus 0, and this is just equal to 2x. So the derivative of x squared is equal to 2x. Now, what if the question asked you, what's the rate of change of the function x squared at x is equal to 3? Well, you already have the general form for the derivative for x squared, which is 2x. So what you can do is you can just substitute it in. So 2 times 3 is 6. And that's pretty much it. Alright guys, that's the end of the video. Thanks for sticking through. And if you made it this far, make sure to drop a like and hit the subscribe button. And make sure to follow my TikTok for some interesting short clips on AP Calculus. And I'll see you again next video.